Welcome to triangle theorem. All right, so first we're going to look at a definition, and then we're going to look at some properties of triangles, and I'm going to move this box out of my way. There we go. All right, so angle relationships and triangles. So a couple vocabulary words for you. Interior is the set of all points inside a figure, and exterior is the set of all points outside the figure. And you have this exact diagram and all of these notes in your notes, so you can just follow along with me. So I have a triangle here, and in my triangle we have 3 interior angles. So those are angles formed by the sides of the triangle, and they are inside the figure. They're inside that polygon. We also have exterior angles. So if I were to just extend, and it's already been extended for us, but if I were just to extend one of the sides of the triangle, we would have an angle created by that line I just drew and one of the sides of the triangle. And I could do that here, right? And here I have an exterior angle, okay? I'm going to write in the words exterior angle. And you can do the same thing to show that there's more than just that one exterior angle that's drawn in. Actually, there's an exterior angle at every vertex of the triangle. So exterior angle. There we go. So there's 3 exterior angles for you. So exterior angles are formed by one side of the triangle and an extension of an adjacent side. And we'll look at exterior angles a little later on. Let's look a little bit more at the interior angles of a triangle. Okay, so triangle sum theorem. Well, this was a theorem we've talked about, but now we're actually going to do a little bit more. We're actually going to prove the triangle sum theorem, prove it to be true, and then we'll also solve some problems with the triangle sum theorem. So just as a reminder, triangle sum theorem, the sum of the measures of the angles of a triangle is 180 degrees. So if I add up all the angles in the triangle, they're going to add to 180 degrees. And you've kind of just taken that on faith. Well, now we're going to prove it. And you might be asked later on to prove this theorem as well. And really, if you can follow along in the steps and explain it in your own words or write a similar proof, you'll be able to do just fine on that. All right, so we're given a triangle there, and this is in your notes. Triangle ABC is what we're given. You can see the triangle there that's formed by those 3 points. And we also have line P, which is parallel to segment line AB, and it intersects our triangle right there at point C. Excuse me. My throat must be dry. Not a lot of talking today. I hope I don't cough too much. Or I may have to pause the tape and create 2 short tapes. So, how do we know that line P is parallel to line segment AB? Well, first of all, I just told it to you. But second, and it's been told to us. But second of all, we know that from our constructions work, anytime we have a line, we can construct a line parallel to it. Right? So anytime there's a line, you can always have a line parallel to it. And it's important for this proof that line P here is parallel to line AB. So I just marked in that line P and line AB are parallel with some parallel line markings. All right, so you have this proof in your notes as well, so just kind of follow along with me. All right, so statement 1. Ooh, so sorry. First thing I'm going to say is I'm going to say my givens, right? I'm going to say triangle ABC. It's important that we know that's a triangle, right? We're trying to prove something about the triangle, and what we're trying to prove is we're trying to prove that those angles add up to 180 degrees. So in your notes, you can write triangle ABC. And we can also write line P, and I'm going to abbreviate parallel, and line segment AB. And I'm going to use that to just abbreviate that. And of course, that was a given. It's right there up on the top, right next to the words given. Right? That was pretty easy to figure out. All right. So what else can I say about this triangle? Well, I'm actually going to come back. Maybe, no, let's deal with that. I have 2 ways I could go. And really all it is a reordering of the same steps. Right? I think that maybe we will talk about the parallel lines first, And then we're going to talk about something else that we can also say. All right, so maybe you don't, if you're looking at that diagram, you might be, oh, I don't know, what does it matter that those lines are parallel? How does that help us? Well, let's maybe extend this line here. All right, so you notice here you've got parallel lines cut by a transversal. Right? And you should see that maybe there's some angles that might be congruent. Right? Hopefully, you see that this angle here is congruent to that angle right there. Right? So I have parallel lines. We have a transversal that intersects those parallel lines. And when it does so, it creates some angles. And there's something special about those angles. So I'm going to say that angle, I'm going to call that angle 2. I think that's clear that that one is angle 2. Is congruent to angle, and that's going to be, I can just say angle B. There's only one angle that we're really interested in, and that is the interior angles of the triangle right now. So I think it's fine if I say angle B. Right? I could also say angle CBA, but I think it'll just be fine if we name it angle B. And why are those angles congruent? Well, that's because they're alternate interior angles created by parallel lines. And we know those are always congruent. Right? Well, what else can I say? Well, that's not the only transversal we have. What if we extend this one here? I think I have some other angles that might be congruent. Angles that are on the opposite side of that transversal, between those two lines. Right? Those would also be alternate interior angles. And you know what? Let's just make that one step. Rather than writing alternate interior angles created by parallel lines, are congruent. Should have finished my thought there. Are congruent. Instead of writing that twice, let's just have two things under number 2. And we can also say that angle 1 is congruent to angle A. All right, well, we've got some congruent angles. You might be, gee, how does that help us? Well, I think my next step might help you see where we're going with this proof. So I had the option of switching these two steps. It doesn't make really any difference because step 3 doesn't have anything to do with step 2. Step 2 relates to step 1. Step 3 relates to my diagram. All right, so I see something special about angle 1 and angle 3 and angle 2. If I were to add those up, how many degrees would those be? 180. Why would those be 180 degrees? Well, notice that together, those 3 angles create a straight line. Okay? So why can we say that? We can say angles that create a line or a straight angle are supplementary and add to 180 degrees. And that was one of the things we studied when we were learning about supplementary angles. Okay, so we know that. So I've got angle 1 plus angle 3 plus angle 2 is 180 degrees. Well, you know, I noticed that here I have an angle 2, and here I have an angle 2, and that angle 2 is equal to something. What if we were to replace the angle 2 in that sentence there with an angle B, what it's equal to? So angle 1 plus, I'm going to leave that one blank for a second, angle B equals 180 degrees. Well, I also notice that's not the only thing that's congruent. I notice I have an angle, oops, I wrote the wrong one in. Erase angle 1. Angle 1 here is right here, and angle 1 is also equal to something. What if we replace the angle 1 with an angle A? Now we're not doing anything with the angle 3. Now I have angle A plus angle 3 plus angle B equals 180 degrees. And notice that angle C here is the exact same thing as angle 3. I probably should have called it angle, now that I think about it, I forgot what my picture was. I should have just said angle 3, because angle C and angle 3 are the same things. Angle 3 is right there in the picture, and I could also call it angle C. So angle 3 or angle C, they're the exact same angle, right? I could put angle C equals angle 3. That's just two ways to name that angle. And notice here, we have added up, let's get rid of all these lines, oops. They're super helpful, and I'll probably put them back in a second, but notice that we have, this is angle A right here, and this is angle B, and this is angle 3 or angle C. Two ways to name that angle there, right? We know we have several ways to name an angle. It's talking about the exact same angle. Add up to 180 degrees, and that's just what we have here. Look at that, we proved it, except we got to add one more thing. We didn't say why I could say angle A plus angle 3 plus angle B equals 180 degrees. I hope you know the reason. I said the word replace, and another word for replace is substitute, and that was the substitution property. All right, so we simply replaced one angle with something it was equal to. And there we go, we proved it. Right? I should probably put those markings back here, because I think those are pretty helpful so that you could see how this proof all goes together. And you should put, maybe you'll draw that line straighter than I just did. And you should put these lines in your notes as well, so that when you're looking at your notes, and maybe somebody asks you to be able to explain this proof, you'll be able to do it, because you'll remember how we did it, that we had a parallel line and our alternate interior angles are congruent, and then by substituting those angles that they're equal to that are outside the triangle with angles that are inside the triangle, we now have the statement that the interior angles of our triangle add to 180. And so all we did was substitute in equation 3 those angles that are in our triangle to get equation 4 there. All right? So hopefully this all makes sense to you, and if it doesn't, I can go over it again. All right? So we had some given information. We used our parallel lines. We used the fact that angles that create a straight angle are supplementary to show that there's no two ways about it. The angles in a triangle add up to 180 degrees. So now we've proven it. Right? Make sure you understand this proof and you remember and you took good notes. Okay? So now let's do something with that, and you have these problems in your notes. I'm going to do 4 problems. These were a little harder than some of the ones that we did earlier in the year when we first talked about the triangle sum theorem, before we proved it. We want to find the measure of each angle in our triangle here, and we know that those angles add up to 180 degrees, right? So the angles in a triangle add to 180 degrees. So if I take 3x plus 2x minus 4 plus 7x plus 4, they're going to add to 180 degrees. So you can just do this one along with me in your notes. So 2x plus 3x, that's 5x. 5x plus 7x, that's 12x. And well, negative 4 plus positive 4, well, that's 0. So I have 12x equals 180. And if we divide both sides by 12, x is going to equal, well, 10 times 12 would be 120. So I'm 60 away. And 12 times 5 is 60. So 60 plus 120 is 180, and 10 plus 5 is 15. Right? So there you go. X is equal to 15. Are we done? Now, a very important thing to do when you're asked a question is go back and check to see if you answered the question. Notice it did not tell me to find the value of x. It said find the measure of each angle. And you'll probably have a question like this on a final. And I'll also ask you to find the measure of each angle. Make sure you find the measure of each angle. All right, so that's not too hard to do. We'll just substitute the value of x in each expression. And by the way, once you know the measures of the angles, you could always check yourself adding them up and see if they add to 180. If they don't, then maybe you've made an error when you were solving. So 3 times 15, actually I'll write them next to the angle itself. There's plenty of room, it doesn't take a whole lot. 3 times 15 means this angle is 45 degrees. 7 times 15 plus 4. 7 times 10 is 70. 7 times 5 is 35. So 70 plus 35 is 105. Plus 4 is 109 degrees. And then we have 2 times 15 minus 4. All right, so 2 times 15 is 30, minus 4 is 26 degrees. And there's the measures of all our angles there. So 45 plus 109, that's 154. And 154 plus 26, actually let's write that down. So 109 plus 45, right, that was 154. And, whoops, and 154 plus 26 is going to give us 180. Okay? And it works out, right? So that must be correct. Let's do another problem. I actually have 3 more problems for you. Right, so we want to find the value of each variable, and we got 3 variables there, x, y, and z. Now, one of these variables would be smart to start off with, and the other ones, well, you just couldn't do anything with those. Hopefully you see that x here is the one that would be smart to solve for, because you already know 2 angles in this triangle. Right, so we have x plus 39 plus 65 equals 180. 39 plus 65, that was 40. 40 plus 65 is 105. So it's just going to be 1 less because that's 39. So it's going to be 104. So x plus 104 is 180. If we subtract 104 from both sides, we get x is equal to 76. All right, we're not done. We got 1 angle. I hope it's clear. Z, by the way, is in that corner there. Notice that x plus y are a linear pair. Okay? And we know a linear pair are 2 angles that form a straight line. All right, so that means x plus y equals 180 degrees. Well, we already know x is 76. And so if we subtract 76 from both sides, we get that y is equal to 104. And now we know 1 angle in this triangle, in triangle GJH, or GH, skip the I, J. And now we know this one. We know y is 104. I'm actually write those in there. This one here was 76. This one here is 104. So if we add, so I'll put it over here, 21 plus y plus z add up to 180 degrees, right? Because they're angles in a triangle. And actually the same thing over here too. I could have written that down. Angles in a triangle. And since when is angles? I put triangles in a triangle. How are you triangle in a triangle? Angles in a triangle. There we are. All right, so now we can substitute 21 plus y was 104. Although I have to say this 104 up here looks a little bit like a 101. So maybe we should make them look more like a 104. And then plus z equals 180. 21 plus 104 is 125. And so if we subtract 125 from both sides, we'll find out that z is equal to 55 degrees. And if we add up 55 plus 21 plus 104, you're going to get 180 degrees. Right? And if you add up 39 plus 65 plus 76, you're going to get 180 degrees. So we did a good job. We found all those angle measures. Let's do 2 more. Ooh, we can do it. All right, find the measures of each angle. All right, we'll add those up. All right, we know that the angles in a triangle add to 180 degrees. So we have 4x plus 7 plus 8x minus 1 plus 90 degrees. That's a 90-degree angle. They're going to add up to 180. Add up your terms with a variable, right? Your like terms there, and then add up your numbers. Put those all together. I would simplify everything on one side and then isolate x. So I have 4x plus 8x. That's going to give me 12x. 7 minus 1 is 6, and 6 plus 90 is 96. All right, and we subtract 96 from both sides. We get that 12x is equal to 104. Well, if it was 120, x would be 10. But it's not 120. It's a little bit less than that. So how many times does 12 go into 104? So make sure we roll the numbers down right. Does that go in evenly? 7. No, 7 would be 84. And 8 would be 96. And so it's not going to go in evenly. That's going to be a weird number. I didn't write anything down wrong. Nope. 90 and 7 are 97. Minus 1 is 96. No matter how you look at that. And 8 and 4, I didn't miss any x's there, they add up to 12. So, yeah, that's what it is. That's all right. And 180 minus 96 is definitely not 104. No. Well, that would be our problem. 180 minus 96 is not 104. 180 minus 76 is 104. 180 minus 96 is going to be 20 less than that. That's going to be 84. Well, it's 7. I know the number seemed a little odd. Not that it couldn't be an odd fraction. You know, those are a thing that says that these have to be integer values for our degrees, but I didn't think I put one in that had a fraction. I just wrote down the wrong number when I subtracted. Oh, well. All right, so now we want to find the measure of each angle. All right. And so we can't just stop at finding x. All right, we already know the 90-degree angle. No point in, we don't need to do anything there. But let's plug in the 7 here. And so we have 28 plus 7 is 35 degrees. And 90 plus 35 is 125. So we need another 55 more degrees. Let's see if that's 55 degrees. 8 times 7 minus 1. 56 minus 1 is 55 degrees. So notice that our angles add to 180 degrees. And we got that correct. And we have one more problem. All right, so we want to find the value of x. To do that, we're going to have to find some variables that we don't really need to find, or some angles, I should say, that we don't really need to find, like this one here. I guess we'll just call it y, because that one there will help us find this one here. Right? We know that the vertical angles here are congruent, and this is the last one in your notes. All right, so once we know one, we know the other, and then we'll be able to solve for our missing angle. All right, so we know that if we add up y plus 43 plus 57, that has to add to 180 degrees, because the angles in a triangle add to 180, right? So that means y plus 43 plus, might not add them together, I have no idea. Let's add them together. 43 plus 57 is going to give us 100. Which means we're going to, subtract 100. Make sure you do this in your notes with me, but maybe you will write the correct number down. That means that y here is 80 degrees. Not the variable we were looking for, but now we know this y is 80 degrees and this y is 80 degrees because those are vertical angles. And now we could add up the angles in our triangle, and this is a pretty easy problem to solve, right? Because those angles also have to add up to 180, because we know the angles in a triangle add to 180. All Right, so we have 2x plus 80 equals 180. If we subtract 80 from both sides, we get 2x equals 100, which means x is 50 degrees. And notice that 50 plus 80 equal 180. And so does 43 plus 57 plus 80 also adds up to 180, because we know all the angles in a triangle always add to 180. All right, well, I'm done with this podcast, and I'm going to see you in the next podcast where we'll talk a little bit about exterior angles. Bye for now.